In this video, we're going to explore Python unit testing and how to write effective test cases using the unit test module. Unit testing is a crucial part of software development, helping to ensure the reliability and correctness of our code. We will see how to use Python's built-in framework and write test cases using the unit test module. We'll cover everything from the basics to more advanced techniques. So, what exactly is unit testing? Unit testing involves testing individual components of your code in isolation. This means that each part of the code is tested independently to ensure it works as expected. Unit tests form the foundation of test-driven development, where tests are written before the actual code. Unit tests automate the validation of code changes, helping to detect bugs early in the development process. Let's explore the unit test framework in Python. First, it is Python's built-in framework, meaning it is part of the Python standard library, so no additional installation is required. Secondly, it follows the XUnit style, which is based on Java's JUnit and follows the XUnit testing pattern. The framework also supports test discovery, automatically discovering and running tests in modules, classes, and functions. Finally, it contains rich assertions, providing a variety of assertion methods to validate test results. Let's dive into the basic structure of a unit test using the unit test module. First, import the unit test module. Next, create a class that inherits from test case. All test methods must start with test underscore. Then, use setup and teardown for fixtures, which are explained in the next slide. To run the test, use unittest.main with parentheses. Here is a simple example of a basic test structure using the unit test module. You can see that it imports unit test, creates a class called testCalculator that inherits from unittest.testCase, and implements setup, test addition, and teardown methods. Finally, it runs the tests using unittest.main with parentheses. To validate test results, the unit test framework provides various assertion methods. Let's see some common assertion methods. The assert equal method verifies that A equals B. The assert not equal method verifies that A does not equal B. The assert true method verifies that X is true. The assert false method verifies that X is false. The assert is method verifies that A is B, meaning the same object. The assert is none method verifies that X is none. The assert in method verifies that A is in B, for example, an item in a list. Finally, the assert raises method verifies that function with arguments raises exception exc. Now let's learn how to write test cases using the unit test module. In the left block we have the code to test. It defines a calculator class with add, subtract, multiply, and divide methods. In the right block we have the test case. It imports unit test and the calculator class. It also creates a test calculator class that inherits from unittest.testCase. Inside this class, the setup method instantiates a calculator object, and there are test methods for addition and division. The test divide method also checks for value error when dividing by 0. Test fixtures are essential for setting up the test environment and cleaning it up after the tests. There are 3 types of fixtures. Method-level fixtures use setup, which runs before each test method, and teardown, which runs after each test method. Class-level fixtures use setup class, which runs once before all tests, and teardown class, which runs once after all tests. Module-level fixtures use setup module, which runs once before all tests in the module, and teardown module, which runs once after all tests in the module. The code on the right shows how to set up a module, class, and method-level fixtures. To run tests, there are several execution methods we can use. Command line execution allows us to run tests directly from the terminal. Test discovery automatically finds and runs all tests in a directory. Test suites allows us to group tests into custom suites for organized execution. Finally, tests can be run directly from IDEs like PyCharm or VS Code. The code on the right shows the different commands for running test cases from the terminal. It's important to test whether code raises expected exceptions under specific conditions. There are different exception testing methods that can be used. The assert raises method verifies that the correct exception type is raised, but does not check the exception message. The assert raises regex method verifies both the exception type and that the exception message matches a regular expression. Both methods can test with a context manager or by passing a callable function and its arguments. On the left block, the code shows how to verify exceptions using assert raises and assert raises regex methods. To write effective unit tests, here are some best practices to consider. Use descriptive test names that clearly indicate what is being tested and the expected outcome. Each test should be independent and not rely on the state from previous tests. Don't just test the happy path, include tests for edge cases, boundary conditions, and error scenarios. Tests should execute quickly, as slow tests discourage frequent test runs during development. Ideally, each test should verify just one behavior or condition for more precise error localization. Mock external dependencies carefully, but don't overuse mocks, as they can make tests less reliable and harder to maintain. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.